Client-side prediction is the innovation that made online multiplayer gaming possible. In the 90s, when online games became a thing, software engineers were looking for a way to make the gaming experience run more smoothly. You have to keep in mind that this is the era of low-spec machines, low-speed internet, and very skilled game development teams. And as often in life, when people work under huge limitations, they start innovating the most creative ways to overcome their challenges. In order to understand how prediction works, let's start with latency. Latency is the delay between an action like pressing a button and the corresponding response in the game. It is measured in milliseconds, or seconds in case you live in the Balkans. Ping is a specific measurement used to estimate latency by sending a data test packet. So lower latency means a faster response, and higher latency means delays and smashed keyboards. But why do we experience latency? So when the client sends a command, the data must first travel to the server. This takes time. For example, let's say 50 milliseconds. The server receives the data, processes it, and sends an updated game state back to the client. This takes, let's say, another 50 milliseconds. The game state on the server side is called authoritative game state. So, in practice, if a player would press a command to move the character, we would need to wait for the server to update the game state, send it back to the client, and then the changes would appear on the screen. There are a lot of factors that influence the latency, like for example network quality and distance to the server. Now, in slow-paced games like chess, this split-second delay wouldn't make a huge problem. But in fast-paced games like first-person shooters, latency can lead to very profound conversations with strangers on the internet in the in-game chat. In order to reduce the impact, not the actual latency but only the impact, developers have came up with prediction. Now, client-side prediction or just prediction is a technique that smoothens out the perception of latency. How does it work? When a player/client performs an action, let's say they press a command to move the character, the client sends out a command and updates the game state locally, without delaying the action and waiting for a confirmation from the server. So it predicts the outcome and updates the game state on the screen. For the player, this looks like the game has instant responsiveness and zero delay. In the meantime, the server receives the player action, updates the authoritative game state and sends it back to the client. Now we have two scenarios. First scenario, the client-side prediction matches the server game state. In this case, nothing happens, the game continues smoothly. Second scenario, we have a mismatch of the game states on the client and server side. What happens now is the client has to reconcile the differences. It starts routines for state corrections, rollbacks, and so on. Visually, you can see effects like the character snapping back to an old position. The player then usually starts clicking very hard and typing very fast. Now you're probably wondering, or maybe not, what happens when a lot of commands start coming in? Well, there are different acknowledgement strategies, but in general each command that is sent to the server has a tick number embedded in it, and each acknowledgement message from the server has also a tick number in it. You can imagine this like a timestamp. In my last video I was talking about the Quake net channel header. They use sequence identifiers instead of ticks, but it has basically the same purpose. Some strategies are batch acknowledgement, where the server gathers multiple commands together and sends out a single acknowledgement for the latest known state rather than confirming each command individually, and individual acknowledgements, where the server acknowledges each command separately so that no critical input is missed. Now, what can we learn from all of this? From a meta perspective, this teaches us that even though sometimes we might encounter hard technical limitations, like latency in this case, there are still ways to overcome it. And I'm pretty sure that when the idea of client-side prediction was first proposed, many people laughed at it and came up with all sorts of reasons why it would never work. And I'm not only talking about programming here, you can also see it as a general life concept. So that brings us to the end of the video. If you liked the content, then like and subscribe, and see you in the next one. Tariq.